Okay, today we're going to talk about classifying quadrilaterals. Now remember, a quadrilateral is a polygon, a two-dimensional polygon with four sides. And there's going to be a number of different polygons that we're going to, or quadrilaterals that we're going to talk about today. And we're going to talk about how to classify those and understand some of the special properties that allow us to solve for some unknowns. Okay, so we will have some different types of quadrilaterals here, and I want to give everybody an opportunity to copy these down, and I'll back up to the first page in just a minute. But we have a number of these, and it's going to take a few minutes to copy down, so I'll give you a couple minutes. I'm going to pause and do this. The first one's a parallelogram, which both pairs of opposite sides are parallel. We have a rhombus, in which all four sides are congruent. And we have a rectangle, all four angles are 90 degrees. Okay, here are two more. A square, which all four sides are congruent, and all four angles have 90 degrees. Now part of that is the same as a rectangle. Okay? A kite, which two pairs of adjacent sides are congruent, and the opposite sides are not congruent. So these would be the adjacent sides that are congruent, right here, two pairs, and the opposite sides are not congruent. Okay, two more. A trapezoid has exactly one pair of parallel sides, and an isosceles trapezoid, which I'll slide up in just a minute, is a trapezoid with non-parallel sides that are congruent. Now, I'll slide the drawing up on that one in just a minute, but there's two types of trapezoids here. Now, we're going to talk about some special properties of isosceles trapezoids, maybe by Christmas break, but I'm going to probably say after Christmas break, because just like an isosceles triangle has some special properties, an isosceles trapezoid has some special properties which we can apply. Highly likely we won't get to it till after Christmas, but we'll see. Okay, now, remember, we're going to be classifying different quadrilaterals today. And one of the exercises in which we're going to be working on is you're going to have to graph points and draw on a coordinate plane the quadrilateral. Then using the notes we just took, you're going to have to classify some of those quadrilaterals. Now, we've talked about those different quadrilaterals having parallel sides, okay? And some of them are congruent. Well, we need to review again how to determine parallel sides, okay? Remember, slope is determined with this, which I hope is still on your formula sheet.
What is that?
Remember, I just take 2 points. For example, if I had point 3, 2, and 4, -1, I could determine the slope by using this formula. Remember, I say x1, y1, x2, y2.
Mr. Dew, I need you to
And I just plug that information in. Now, this isn't new stuff. So, when we talk about parallel lines, if our slope is the same, they're parallel.
Flippy switch it.
If they're perpendicular, listen up. If they're perpendicular, we flip the slope and change its sign, which is the flippy switchy thing. So we flip it over and change it to its opposite. For example, Guys, listen up. For example, if I had a slope, which is represented by M here, of negative 3/5, okay?
Yeah, we got all
Slide
day.
up here.
Hey guys, quiet down.
Hey, listen up. What would be its perpendicular slope if I had a slope of negative 3/5? Okay, so I flip it, and I switch it. So it was a negative, and now it's going to be a positive. Now you don't have to write the positive. I'm just showing that so you can see it's a flippy switchy. Just a second. You need to move it, have it moved. Okay. Very good. Now, if my slope is 5, what's my perpendicular slope? Now remember, 5 can be written as 5 over 1. So I flip that. It's 1 over 5, and it was positive. It now becomes a negative. Okay? So I'm going to move this. Now, as I said to you, we're going to make this into a flow chart. Now, this is the quadrilateral hierarchy.
We gotta write that down.
Yep. Now, some people might like to see this visually up here. If you open your book to page 289, you can see another flow chart of this. You always start up at the top, and based upon what information, whether it has no parallel side, one parallel side, or two parallel sides, you follow it down. So take a few minutes to either draw this, and I'll have to move it up, or open your book to page 289. It's easier to draw it out of there. I want you to copy these two polygons, or quadrilaterals, down. Quickly and quietly, and only put the information that's there. And we'll talk about classifying this.
On the test, there'll be questions like this that say classify the quadrilaterals. And I caution you, you can't just look at this and say, well, that's a square because it looks like a square. Neither of these are squares. Okay? Neither of these are squares. We can only base it on what they gave me. All four sides here are what? They're equal. In fact, they're equal to 5, right? So what has the rule that all four sides are equal? A rhombus. So this picture on the left is a rhombus.
And that was a rectangle.
And that's right. This one over here, all we know is that the four angles are 90 degrees. They're all right angles. So therefore, it is a rectangle. It may look like a square, but we don't know that. Now, having said that, I just talked about test questions. The first few questions in the homework say, judging by appearance, what shape are these? Well, if you just went by appearance, then we would call both of these a square. The test question doesn't ask that by appearance. It says classify what it is. Based on the information they gave you, you know to be true. Okay? Devin?
Was 5.
Help me out here, Devin. How do I set this up? This is the last one.
4x minus 8 equals 6x.
Okay, Billy says, because these sides are the same, 4x minus 8 is equal to 6x minus 20. Okay? Come on, write this down. That's correct. Hey. Because this is a kite, these two sides are equal. What's that mean about these two sides down here? They're equal also. And so the other one would say 7y plus 15
equals 4y plus 27.
That's right, equals 4y plus 27. Does anybody want help solving these two?
No.
Okay. Fix all. We're actually looking at today's homework as what was Monday's 6-1, 1 through 26 all.